Section 3, Crystals and Polymers. Just like the other videos, I will read through the section and then go over the questions in your ISN notebook. Did you ever build structures with toy bricks? By snapping them together, you can build structures that go on and on forever. Are there any molecules that can go on and on forever? Crystals. Molecules do not go on forever, but there are other structures that could. A crystal. A crystal is a solid structure whose atoms or molecules are arranged in repeating three-dimensional subunits. Crystals can be formed with only one element or with multiple elements. Crystals are structures that could go on forever in all three dimensions, like a chain of bricks. Some crystals are made up of one element. Diamond is a crystal made of one element, carbon. The subunits that make up a diamond crystal look like a cage made of carbon atoms. This cage-like structure repeats over and over to form the diamonds in jewelry. Crystals can also be made up of multiple elements. Solid sodium chloride, also known as table salt, is another crystal made of repeating subunits. Each subunit is four sodium atoms and four chlorine atoms, alternating to form a cube, as shown in Figure 3a. Table salt is also called NaCl because the sodium and chlorine atoms are in a 1-to-1 ratio. So here you can see the picture of the table salt, and it's a 1-to-1 ratio, so you only have to write it as NaCl. The green are the chlorine, and the blue are the sodium, and it forms a cube-like structure, as you can see here. Okay, not all crystals have a 1-to-1 ratio of elements. Quartz, a mineral found in stones such as amethyst and sand, is a crystal made of silicon and oxygen atoms bonded together in a 1-to-2 ratio. One crystal of quartz may have 100 silicon atoms and 200 oxygen atoms, or 224 silicon atoms and 448 oxygen atoms. However, all quartz crystals have silicon and oxygen atoms in a 1-to-2 ratio. So no matter how many silicon atoms there are in the quartz, there will always be double as many oxygen. So table salt and quartz are two of the many different crystals that are made of multiple elements. Just as individual atoms can come together to form crystals, so can molecules. Strong chemical bonds hold together the atoms within a molecule, while other attractions hold together the molecules within a crystal. As with crystals of atoms, the molecules within the crystal are arranged in a regular repeating pattern. Table sugar is a crystal of sucrose molecules. The molecules stack on top and around each other to form a crystal. Similarly, water is also a molecule that forms crystals when liquid water freezes to form ice. These molecules are arranged in a regular repeating pattern. Polymers. Crystals are not the only structure that could go on and on. A polymer, which is another one of our vocab words, is a structure that is made of smaller repeating subunits in a chain. Unlike crystals, in which the subunit could be atoms or molecules, in polymers the subunit is always a molecule. Many everyday objects are made of polymers. For instance, sports uniforms are made of a polymer called polyester. Polyester is made of repeating smaller molecules called ester molecules. So for instance, poly means many, and they're made up of ester molecules. So polyester literally means many ester molecules. The plastic in many water bottles is also a polymer called polyethylene terephthalate. Oh, sorry, I don't really know how to pronounce that, but you can call it PET for short. Many water pipes around the United States are made of a polymer called polyvinyl chloride, or PVC. So here you can see the chain-like structure in the polymer that is polyester. It repeats on, and it is made of only molecules. Polyester, PET, and PVC are all polymers that humans invented. However, you are actually filled with polymers. The proteins that make up your muscles and the DNA that gives you your traits are all polymers. All of these polymers have something in common. They are made of many smaller molecule subunits that are bonded to each other in a chain. Extended structure, that is also one of your vocab words, so you know it's important. Crystals and polymers are part of a bigger category called extended structure. Okay, so here's the definition of extended structure. A structure whose subunits occur in a constant ratio and are arranged in a repeating pattern. It can be individual atoms or a molecule. So both crystals and polymers are extended structures, which is basically what the definition is saying. An extended structure has repeating subunits of atoms or molecules arranged in a specific pattern. As a result, an extended structure has a constant ratio of atoms. Unlike the molecules you have learned about, an extended structure does not have a specific composition. The composition of a molecule describes each atom of each element in that molecule. A water molecule has exactly 2 hydrogen and 1 oxygen atoms. In contrast, the composition of an extended structure is the ratio of elements that make it up. Table salt has a 1-to-1 ratio of sodium and chlorine atoms. It does not matter if it has 100 of each or 10,000 of each. The ratio will always remain the same. Okay, so this one you can do on your own. You are just deciding if it is a crystal or a polymer. We went over each one of these examples in the reading, and you can do it as many times as you'd like. It's just to check for understanding. Okay, so question number 1, describe the difference between a molecule and an extended structure. So we just read what extended structure was in this section right here, and we already know what a molecule is from our previous reading. So we should be able to describe the difference here. But in case you are confused, I will give you a few hints as what I wrote in my answer. So I'm going to start by explaining what a molecule is and why it's different. We know that an extended structure can go on forever and ever, but we also know that a molecule cannot. So that's what we can write down for our difference. A molecule has a discrete endpoint, while an extended structure can go on forever. That's really all you need to include. You don't need to do an entire paragraph or talk too much about the differences. It's just asking for a sentence, and as long as you've included at least this much, then you're good to go. So now we're going to be filling out the blanks for the following crystals. As we know, crystals have specific ratios, like right here, table salt, 1-to-1. So if the sodium atoms are 275. We know that chlorine will also be 275 because it's 1 to 1. So now if we're doing quartz and it's 1 to 2, the 2 being the oxygen atoms, as we see here, there's 560. So we could just take 560 divided by 2. I'll write that right here so we understand what we're doing. Divided by 2 to find our answer right here, which would be 280. So the ratio is 1 to 2, the 1 being 280 and the 2 being 560. So I know that you can do the rest of these on your own, but I am going to show you how to do these because the ratios do get a little tricky, especially on this iron rust. As you can see, written in the crystal is the atomic composition. So you can see how that's coming up again. And we're going to be using it the rest of the time that we are talking through this book. So make sure that you understand atomic composition because it's not going to go away. So for example, iron rust atomic composition is Fe2, so 2 iron molecules and 3 oxygen molecules. The ratio is 2 to 3, and you can see looking at the atomic composition, that's where we got that ratio right here. There's 2 iron and 3 oxygen. So if there are 3 oxygens, and the ratio is 2 to 3, we are going to take this 744, we're going to divide it by 3, to get our answer of 248. So 744 divided by 3 is 248. But since we know that there are 2 iron molecules, we will times this by 2 to make sure our ratio is correct, and it's 2 to 3. If the ratio were 1 to 3, 248 would be our answer. But since it is 2 to 3, we need to multiply it by 2 to get 496. Which is where we can write right here 496. That is where we can see our ratio 2 to 3. So in this final crystal example, we are getting the number of atoms, and we need to figure out what the ratio is. So let's start by dividing 504 by 252. And if we do that, it actually gives us our answer. The ratio is 1 to 2. Okay, so we are adding in a little bit of math here, so I know it can get tricky, but it's basically just finding the ratios and finding how many of each atoms are in each crystal. Okay, so our final question is, crystals and polymers are different types of extended structures. Think of a crystal of molecules such as ice. What are the similarities and differences between a crystal of molecules and a polymer? Okay, similarities. This is where we can look back in our reading to figure out the similarities and differences. But since we already went through all of that, I'm just going to type it in some bullet points here. We know that both of these are made up of molecules. So I'm going to type that. We also know that they're both extended structures, so they can both go on forever. And since they can both go on forever, they are both extended structures. So that's what we're going to write for our similarities. And our differences, remember, polymers are a chain, like we learned up here. Polymers are a chain, while crystals extend in all three directions. So that is what we are going to write down for our differences. And that is all we need to do for section 3. If you have any questions, you can email or send a Zoom message to your teacher, or you can rewatch this video and reread this section.